Hello students, welcome back to the sixth video of this playlist. So in this video we will be solving question number 6 from P4 October 2023 paper. So let's see question number 6. Basically question number 6 it's from vectors part. You know vectors, it's discussed in P4 chapter number 7 of your textbook. So in order to be able to solve this question, you should have clear idea about the concepts and the topics that has been discussed in chapter number 7 of your P4 book. So let's get started. Question number 6. The line L2 has equation. Its equation is given in form of column vectors where lambda is a scalar parameter. Fine. The line L2, another equation of line L2 is given in column vectors form where mu is a scalar parameter. Okay. Given that L1 and L2 meet at the point P, the line L1 and the line L2, they are meeting each other at point what? Point P. Okay. So line L1 and L2, they are meeting each other at point P. Fine. So if I show you using a sketch on the right hand side, so this is the axis. So line L1, the line L1, let us consider it goes like this, just a sketch, it goes like this line L1, and consider line L2, it goes like this. Okay, so that line, okay, it got curved, it should be straight. Okay, consider line L2 goes like this. Okay, so the two lines L1 and L2, L1 and the line L2, they are intersecting each other at where? This is basically the point P, right? Okay, so at first they are asking state the coordinates of point P. State the coordinates of point P. Now after like seeing this equation, like this question, you might consider that we should equate the two equation and then equation of the two lines, and then we would get the value for lambda and mu, and then we would get the coordinates of point P. But don't go for that. Since they asked for state, we need to just state. It is just for 1 marks. So how can we state the coordinates? Right. Now look at the equation of the two lines. Can you see a relationship between the two lines? Yes, there is. What's the relationship? Both have the same starting point, and this is basically the coordinates of point P. Understand? This is basically the coordinates of point P. So you can say coordinates of point P is what? Just the starting vector, that is 2 3 minus 7, 2 3 minus 7. This is the coordinates of what? Point P. Done. Straight answer. Okay. Part B. Given that the angle between line L1 and L2 is what? Theta. The angle between the two lines, it is what? Theta. Find the value of cos theta, giving your answer as a fully simplified fraction. We need to find out the value for cos theta. Now, if you have definitely gone through the chapter number 7 of P4's book, definitely you have know something, you have gone through something named as the dot product, the vector dot product. So basically we have to use the vector dot product here to get the value for cos theta. So according to vector dot product, we know that cos theta can be written as what? A dot B over the modulus of A, vector A, and the modulus of vector B. So in that case, what we should use? We will be using, since line L1 and L2, we know that the parameter, the multiple of the parameter, it's basically the direction towards which the lines are passing through. Okay. So what are the like direction parameters here? What are the product of the parameters here? For line L1 this is 1 2 2, and for line L2 this is 4 minus 1 8. So towards the direction of this vector 1 2 2, line L1 is passing through, and towards the direction of 4 minus 1 8, line L2 is passing through. So we will consider the dot product of these two parallel components. So let's do that. First one 1 2 2, right? And the second one, it's what? And the second one is 4 minus 1 and what? 8. So these are dot product over the modulus of 1 to 2 is what? Square root of 2 is 2 square 2 square. This is 4 4 8 9, square root of 9. Fine. And the square root of the modulus of the second parameter, this is 16 plus 1, that is 17. 17 plus 64, that is 81. Square root of what? 81. Fine. Yes, it is 81. Okay. So the value for cos theta would be what? Dot product means what? All the respective I components will get multiplied with the what? I components, like only the respective components will get multiplied and then added up. That's it. The respective components will get multiplied and added up. So I times I, this is what? 1 times 4, this is what? 4. And then what's there? Plus 2 times negative 1, this is what? Negative 1, right? And then 8 times 2, this is 16. 16 over square root of 9 is what? 3, and 3 times 9, this is 27. 27. So the value for cos theta, it is what? The value for cos theta we would get here, it is 4 plus 16, this is 20. So 19 over what? 27. This what we got? Or 2 times negative 1, this is what? Negative 2. It should be negative 2. So this is 18 over 27. So the value for cos theta would be what? 2 over 3. The value for cos theta is 2 over what? 3. That's it. Next, part C. This is simplified form. Okay. For part C, they said the point Q lies on L1 where lambda equals to 6. Point Q lies on L1 where lambda equals to 6. So if you just put lambda equals to 6 into the equation of line L1, you will get the coordinates of point Q. Given that the point R lies on L2 such that triangle QPR is an isosceles triangle. QPR is an isosceles triangle with PQ equals to what? PR. Fine. Q and R. Point R lies on line L2. R lies on line L2. Consider this is R. You can consider this as R. That is lying on line L2. And Q, it lies on line L1. And this is basically the triangle. Let me change the color. This is basically the triangle. Okay, just a sketch. So this is basically the triangle. This is point Q. So QPR is an isosceles triangle. That means this side, this side and that side are equal. Fine. Now, what's the question? Find the exact area of triangle QPR. We need to find out the exact area of triangle QPR. So for finding the area of triangle QPR, what we need? We have to use this formula. What formula? Half of AB sin theta. So since it is an isosceles triangle, we will consider this angle theta. Okay. So half of AB would be what? The length of PQ or PR. PQ is better because PR we don't know R exactly. So PQ, the length of PQ, it's modulus. It should be the modulus. Okay, whole square AB, because AB, the two adjacent sides gets multiplied. So since it is isosceles, so it will be PQ the length would be equal PQ whole squared, okay, times sin theta. We know the value for cos theta. From there we can derive the value for sin theta easily. Okay. Now our first work is to find the coordinates of point Q. Okay. So for part C, we need the coordinates of point Q. So OQ would be what? OQ would be lambda equals to what? 6 there. Lambda equals to 6 there. So 2 plus 6, there is 8. 2 plus 6, there is what? 8. And then 3 plus 12, that is 15. The coordinates of point Q is 8, 15. And then what? Negative 7 plus 12, that is plus 5. Okay, plus 5. We got the coordinates of point Q. Okay. Now our work is to find the vector PQ. Okay. We need to find out the vector PQ. So what would be the vector PQ? Using the triangle rule of vectors, it is OQ minus what? OP. Right? OP is what? OP is the position vector of point P, that is 2, 3, negative 7. 2, 3, negative what? 7. Okay. So 8 minus 2, this is what? 6. 15 minus 3, that is 12. And 5 plus 7, that is what? 12. So we got the position vector of PQ. Like position vector of P with respect to Q, that is 6, 12, 12. So let us find out the distance PQ. So that's the modulus basically. So modulus of PQ would be what? We need the distance, isn't it? To get the distance, to get the length of one of the adjacent sides. So PQ modulus is square root of 6 squared plus 12 squared plus 12 squared, right? So 12 squared is 144 times 2, that is 288. 288 plus 36, 324. The square root of 324 is exactly 18. Okay, it is exactly 18 units. Okay. Okay. Now we need to find out the length, sorry, area. So area would be what? Area of triangle PQR, right? Area of triangle what? Area of triangle PQR. PQR. So that would be what? Half of AB sin theta. So half of 18 squared. Half of 18 squared. It is what? 324. Times sin theta. So sin theta is what? Square root of 1 minus cos square theta. Using the trigonometric identity. 1 minus cos square theta. Cos square theta is what? 4/9. So what would be the exact area? Half of 324. This is basically what? 162. And 162 times what? Square root of 1 minus 4/9. That is 54 square root of what? 5 unit squared. This would be the area of triangle what? The isosceles triangle PQR. Fine. Okay. So we got the area of triangle PQR. Done. Next is part D, the last part of this question. Find the coordinates of the possible positions of point R. We need to find out the possible positions of point R. Now you might get confused here, like how could point R have two possible positions or three possible positions? How it can have? Let's see the diagram, the sketch that I have shown you earlier. Point R lies on line L2. So look, point R lies on line L2, right? So if point R, since point R lies on line L2, which one is line L2? This is line L1. Okay, this was line L2. Okay, this is line L2. Okay, there's problem. It should be line L2, and this is line L1. Okay, so this is line L2, and line L1 is this one where Q lies. Okay, this is just a sketch, not an important thing. Okay, so how could line point R can have two possible positions, or two possible positions maximum it can have. Okay, how did I understand? We already got this is one possible position, and another possible position can be here. This is R1, this is R2. Make sense? Now we need to figure out these two positions. Okay, how can we find out? We will use this concept, PQ equals to PR. Okay, before that, since point R lies on the line L2, so definitely the coordinates of point R will follow the equation of line L2. So what was the equation of line L2? 2 plus 4 mu. So OR, position vector of point R, it is what? It is equals to 2 plus 4 mu, 2 plus 4 mu, and then 3 minus mu, 3 minus mu then, and then say 8 mu minus 3 minus mu. It lies on line L2, right? Okay, 3 minus mu and 8 mu minus 7. 8 mu minus what? Minus 7. 8 mu minus 7. This is position vector of point R. Next, what we need to do is that we know the coordinates of point P. So let us find out PR, right? PR. Let us find out PR. So PR is what? PR is OR minus OP, right? So OR is what? 2 plus 4 mu. 2 plus 4 mu minus what? OP. The I component of P is what? 2. So that should be minus 2. Okay. And then it would be what? 2 plus 4 mu. Then it will be basically, since line point P lies on line what? L2 and also line L1. So basically it will be what? It will be just their common point. Okay, it will be just the component, the parallel component. If you subtract, you will get just like this 4 mu, because their initial point is common. That's why it will be just the parameter. So that would be 3 minus mu. So it will be just mu, negative mu, and then 8 mu. Okay, because point P lies on line L2 also. That's why. Make sense? So we got PR. So PR is equal to PQ, right? PQ. Do we know PQ? We need to. Yeah, we know PQ. PQ is what? 6, 12, 12. PQ is 6, 12, 12. So this is equals to what? PQ, that is 6, 12, 12. Can you consider 6, 12, 12? 6, 12, 12. PQ equals to PR. Okay, but if you consider the values for mu, you will get what? Different. Okay, wait, we need to consider the distance, right? The distance should be equal. Yeah, exactly, the distance should be equal. So consider the distance. PR, modulus of PR is what? That should be 16 mu squared, 16 mu squared plus mu squared plus 64 mu squared plus 64 mu squared. So 64 mu squared, this is equals to what? This is equal to square root of 324, right? We got earlier the 18. It is 18. So length PR equals to 18. Okay. So now what we can write 16 plus 1, that is 17. So square root of 81 mu squared, that is 9 mu. 9 mu equals to what? 18. Okay. So 9, we got 9 mu. It could be plus minus. Why? Because square root of something is what? Plus minus. Okay, this should be plus minus. Yeah, 18. Square root of 324, that should be plus minus. Okay. So you will have two possible values for mu, right? Okay, how did I understand we need plus minus? Okay, how did I understand we need plus minus? Because there is what? Square root. Square root is what? Plus minus 18. So it will be either plus 2 or minus 2. Okay, plus minus 2. Okay, so mu is what? Plus minus 2. Now put the value for mu into the equation of line L2. Okay, if you put mu in the equation of line L2, what you will get? If it is mu equals to 2, if mu equals to 2, then you will get the position vector of point R, OR, that is what? Since they said possible positions, that's why I could understand that it should be plus minus. Okay, so OR would be 2 plus 8, that is 12. 2 plus 8, that is 12. And then 3 minus 2, that is 1. 3 minus 2, that is 1. And then negative 7 plus 16, that is plus 9. So 12, 1, 9. This is one possible position. And the next possible position is for mu equals to negative 1. Okay. The next position is for mu equals to negative 2. Not. Okay, mu equals to what? Negative 2. Okay. If mu equals to negative 2, what you will get? OR, it would be what? It would be 2 minus 8, that is negative 6. That would be what? Negative 6. Negative 6, and then the J component would be what? J component would be 3 plus 2, that is 5. Positive 5. Positive 5, and then negative 7, negative 16, that is negative 23. Negative what? 23. Just substitute the values for the possible values we got for mu. You will get the position vector of R. Okay. So for mu equals to 2, we got 12. 2 plus 8. Oh, it should be 10, not 12. It should be just 10. Correct it. It should be 10. That's it. These are the two possible position of point R. And that's all about question number 6 from October 2023 P4 paper. Thank you.